All right. I'm going to go over a handful of the problems right now. Probably going to break it into a handful of videos for you to be able to watch. I'll do the first 6 from the test. This test right here, first page. The first 6, then I'll do the next 5 in a few minutes. I'm probably going to break it down into a handful of videos for each page of the test, just because it's pretty time consuming to sit and try to erase and rewrite problems and things like that. We'll see how it goes. I don't know. We'll see how you do with this. Now, number one, biggest mistake that some of you made, if you made a mistake on it at all, is that you went out of the order of operations. You can't get rid of the 1 first in the problem. You've got to get rid of the 5. So you've got to multiply both sides by 5. And it's going to end up being x plus 1 is equal to 45. Pretty simple with this. All you do is subtract 1 from both sides, and you end up getting x is equal to 44. Okay? That's about the biggest error that people made, is they went out of the order and they added or subtracted the 1 first. No, don't do that. Get rid of the 5 first. Order of operations means this is like a grouping symbol when you have work above the division bar. So that's the last thing that you touch in that problem. This one, most people did not make any major errors if they did at all. The biggest error is that you didn't graph it, but it didn't say you had to graph it. I personally would have preferred you to do it. Subtract the 12 and 2x is equal to 8. Oh, sorry, not equal to. That's one of the errors some people made, is that they forgot that it was an inequality. And then divide by 2, and x should be greater than 4 in this problem. X should end up being greater than 4. Now, the graph for this one would have been an open circle at 4, and it's all numbers greater than, so it should be shaded to the right. Shaded to the right on that one. This one, several ways that you could have done it. Easiest way, get rid of the 12 first, and you end up with 3/5 x is equal to 27. Multiply by the reciprocal of 3/5. So multiply by the flip-flop, 5/3. So this cancels. Multiply 27 by 5/3. 27 over 1 is 5/3. Now, 5/3. The 3 cancels out with the 27. That leaves you a 9. X should end up equaling 45. That's how the first 3 work out. Look at any errors that you made. A lot of people were freaked out by the fractions in this one. Don't get freaked out. It's just the reciprocal when you want to work it. Now, you could have, when you got to here, multiplied 27 by 5, then divided by 3, or divided by 3, then multiplied by 25. You would have ended up with the same answer of 45 over here either way, but it's easier just to take the reciprocal of the fraction and work it out that way. Now, there is another way to work with fractions, but it's really not applicable to this type of problem, or this problem specifically. All right, now numbers 4, 5, and 6. Okay, 4, 5, and 6 get a little uglier, multi-steppier kind of problems. Now, again, combine the like terms. You've got a 4m and a 2m. That makes 6m. You've got a -5 and a 14. That makes a +9 is equal to 63. You have to subtract the 9. That makes 54. And 6m is equal to 54. Divide by 6. M should equal 9. Okay? Now, here's one that a lot of people messed up on. It's just a ratio, a proportional problem. Some of you did it great. You cross-multiplied 3 times n, that's 3n. This is where some of you made your errors. You have to multiply the everything by 5, okay? So 5 times n is 5n. 5 times 4 is 20. Now you just bring the 5 to the other side, 5n, and subtract it. You're left with a -2n is equal to 20. And when you solve by dividing by -2, n should equal a -10. N equals a -10. Errors that people made on this one, when they distributed the 5, they forgot to distribute it to the 4. They just took 5 times n and made it 5n. Other people put everything on one side. You have to remember, it's an equal sign here. When you cross multiply, this cross multiplication is equal to that cross multiplication in a ratio, or a proportion in this case, I'm sorry. Now, some of you crapped your pants on this fraction problem, okay? The shortcut way to solve a fraction problem is to get rid of the fractions. Multiply everything by the common denominator. The common denominator for all these fractions is 10. Okay, 10 is the lowest common. You don't have to use the lowest common, but you're going to find out that the lowest common is going to make your life a lot easier. That means every piece of this gets multiplied by 10. Now you'll see what happens when you multiply every piece of this by 10. You can cancel. 5 goes into 10 twice. 2 times 2 is 4x. 2 goes into 10 5 times. 5 times 3 is a negative 15. 2 goes into 10 5 times. 5 times 1 is 5x. 5 goes into 10 2 times. 2 times 3 is a positive 6. Look at what you've taken, this hideous fraction problem, multiplied everything by the common denominator of 10. Now, you didn't have to use 10. You could have used 20. You could have used 30. You could have used anything in there that both 10 or 5 and 2 go into evenly. But the lowest common denominator, or least common multiple in this case, is going to make your life a lot easier because the numbers are going to be smaller. Now you have to isolate the variables. Subtract the 4x. That makes a 1x, or just plain x. Move the 6 to the other side. That makes a negative 21. And x should equal negative 21 in this one. Okay? Pretty simple, not too hideous. Those are the first 6 problems. Let's see if we can get a couple of the other ones on the other side. Camera down. Oh, it's coming. Don't worry. Don't freak out. I'll be back. Here I am. Here I am. Let's use this side. All right. Number 7. This guy right here. People were crapping their pants over this one too. Distribute first. 2 times 3x. 2 times 3x is 6x. 2 times 4 is 8. You see what that turned into? 2 times 3x is 6x. 2 times 4 is 8. You just distributed the 3. Now, distribute the half. Half of 12. What's half of 12? Correct. 6x. What's half of 16? It's 8. Now, a lot of you got to this point right here, and you were like, ooh, cool. I subtract the 6x, that cancels. Subtract the 8, that cancels. 0 equals 0 is what you end up getting. I don't even need to go that far. I'm looking at both sides. It's the same expression on both sides of the equation. If it's the same exact expression, I know it's going to be 0 equals 0. That's telling me I can put any stinking number in for x into this problem, and it's going to always be equal. If I put a 2 in here, it's 12 plus 8. 12 plus 8, that's 20. 20 is equal to 20. It doesn't matter what number I put in for this problem, it will always work. That means the answer is all real numbers. Now, some of you used infinite amount of answers. Yeah, that's right. It is an infinite amount of answers, but you've got to tell and explain that it is all real numbers. Yes, as you get further into math, you're going to find out there are things called imaginary numbers, or negative square root of 1, or square root of negative 1. Okay, can't work with that. So it's got to be all real numbers. Just saying that it's an infinite amount of solutions is good, but not perfect. Okay, we want to be perfect. Now, flipping this over, we're going to work on number 8. Number 8, most of you got right. There are 2 ways to work on it. Number 8, where are you? There you are. 4 times the quantity of x plus 7. You could divide both sides by 4. Okay. 4 times the quantity of x plus 7 is equal to 40. You could divide both sides by 4. This cancels out. Divide by 4. And you end up having just a one-step equation of x plus 7 is equal to 10. Subtract 7, and x should equal 3. Now, some of you distributed the 4 and made it 4x plus 28 is equal to 40. It's going to be the same monster. Subtract the 24, you're left with 12. 12 divided by 4, 3. Works out the same way either way. All righty, so far so good. Let's see if we can keep going. We're on fire here. Oh, this next one. The errors that people made with the next one were just so small. Tiny, tiny, tiny. It's an inequality. Some of you are freaked out by inequalities, and that's not that bad. They're all over on this test. You just have to know how to work with them. Negative 3x plus 11 is greater than or equal to 23. It's solved. Any inequality is solved just like an equation. You solve it just like it was an equal sign there, except for one little part. Subtract 11, and you're left with negative 3x is greater than or equal to 12. Not a horrible thing to do. 12 divided by negative 3 is negative 4. That works out just fine. X is not equal to. Some of you put equal signs down. It's not an equal to. And it doesn't stay greater than or equal to, because when you divide or multiply by a negative number, it makes the inequality flip. So the inequality should have gone to less than or equal to. Why is that? Because you're changing the value on the other side to its opposite function, opposite form, from positive to negative or negative to positive. Changing it from numbers by dividing is nothing. That's nothing. Changing the value positive to negative is big when it's an inequality. Now, graphing this sucker would mean that it's less than or equal to. That's a closed dot at negative 4, and that's everything less than, so you'd shade to the left. Now, number 10, I'm going to go through that one relatively quickly because it's not that bad. Distributing, it becomes 6x plus 12, and this becomes 8x minus 32. Some of you made little errors in math there that just made no sense with what you did. Like you distributed the problem, but you forgot the distribution and the equals, what it would end up equaling, and made little errors with your problems there. Now, I'll go through that one, and then I'm going to do the last one really quickly. All righty, here we go. It is 3 times the quantity of 2x plus 4 is equal to 4 times the quantity of 2x minus 8. 3 times 2x is 6x. 3 times 4 is a positive 12. 4 times 2x is 8x. 4 times negative 8 is negative 32. Okay, subtract the 12. That's negative 44. Subtract the 8x. That makes a negative 2x. Negative 44. Negative 2x is equal to negative 44. Divide both sides by negative 2. And it should be x is equal to a positive 22. A lot of people got positive or negative mess ups there, but nothing major. All righty. Last but not least, I'm going to put you down for a second. Don't go away. I'm still here. I'm going to do our last problem. Last problem on this front page. The last problem is absolute value. Some of you did such nice work with this. Okay, 7 times the absolute value of n plus 1 is equal to 35. First things first, you've got to isolate this like it were a variable. You've got to isolate the absolute value, getting all the numbers that are around it away. So the 7 times, what's the opposite of multiplying by 7? Divide by 7. And you're going to get the absolute value of n plus 1 is equal to 5. This is where the blah on the absolute value problems came along for some of you. Some of you distributed the 7 throughout the absolute value. They're not parentheses. That's not what you do with this. You've got to get it so it's the absolute value of whatever plus 1 is equal to 5. And there should be 2 answers for this. You would have n plus 1 is equal to 5, but you would also have n plus 1 is equal to a negative 5. Now, if you remember, the absolute value, when you work with it, should be 2 answers, the plus or minus value of that number. Okay, that's what we're doing here. This absolute value right here is equal to the plus or minus 5, positive or negative 5. And we've got to solve it for both of those equations. You'll see what happens with this. Subtract the 1, and you have n is equal to 4. Subtract the 1 over here, and you have n is equal to negative 6. How can they both be right? Watch. 4, put a 4 in here. What's 4 plus 1? It's 5. What's the absolute value of 5? Oh, it's 5. Put a negative 6 in for the n. What's negative 6 plus 1? It's negative 5. What's the absolute value of -5? How far from 0 is -5? Oh, still 5. All right. I'm going to post this sucker. This is page 1 of your test. All the work that's shown, you can make corrections, you can look at it, write all over the test so you help yourself. So if we do any type of stuff for it, you've got examples of what we're doing within this. More to come, people.